Hello, my dear students. I am B S Pandey, your physics lecturer. My dear students, today we are in lecture number 29 of Newton's laws of motion. And today we will start a very important topic. It is constraints body problem. This particular topic is very important for the competition point of view also. Okay, so look at here carefully for this lecture number 29. It is the Newton's laws of motion, and we are going to start today a very important unit. It is constraints body problem. Constraints body problem. What is mean by the constraints body problem? The constraints body problem, my dear students, it means the one body affect the other bodies. That is, the motion of one body is affected by the other bodies. This is the constraint. Some constraints experienced by one body due to the motion of other body. All right, and when we talk about the motion, we realize the three things. It is the position, that is the distance or displacement, velocity, and acceleration. So in this constraints body problem, we will correlate all the three things. Okay. All right. So to study this constraints body problem, first we will try to understand the virtual work method. Okay. Here, virtual work method to solve the problems. Let us suppose, my dear students, one problem I am drawing over here. I hope you can understand by correlating all the conditions. Look at here, M1 and this is M2. Suppose this is moving with an acceleration A1. Okay, try to understand what I'm trying to say. Here, if this body M1 is moving with an acceleration A1, of course, the length of the string it will release if it is moving from here to here. Suppose a distance x. All right, it is, of course, if x length move forward, here this pulley will goes not exactly x. Why? Because this pulley will release the length two sides around it to move the length, and the two side the length, that is the string, released by this pulley will be equals to x. It means this pulley will release only half the length of this one. But in case if you are not able to correlate how much it will release, if you are able to see, okay, if it goes up, all right, if this pulley goes up, so it will release the total length, and this total length will be compensated by the length over here. If it moves forward, then how much this block will forward, the total length released by this pulley, that is the string released by pulley. And this pulley will release, this is the total, suppose this is the x and this is the x, 2x. It means this will move 2x. So if this pulley moves x, it means the x this side and x this side, the total released length by this pulley will be the 2x, but this pulley moves only x, and so this will move x. Okay, my dear students, here you can see if this released 2x, of course here the 2x it will move, but we have taken here the x. We will try to find out the length. Suppose this moves by y. Okay, how much it will move, the body it will move, and how much it will move we don't know. We are going to use here the virtual work method to find the relation between displacement, between velocity and between acceleration. Easily we can correlate. So try to understand this method. What is the virtual work method, my dear students? One thing you know that about the work done. We have studied about the work done. What we have studied? The work done, it is force into displacement. Force into displacement. You have studied in standard 9th. Okay. Here, the work done, and this work is also the form of energy. You know that. And energy must be conserved if there is no loss of energy. Alright. If there is no loss of energy, then it should be conserved. Work done, because this system is internally isolated. If work done by this M2 is W, then this will be also W. And work is force into displacement. Okay. To displace this M2, how much force is acting, it will decided by this string. And to displace this body, how much force is acting, it will be decided by this string. So try to find out the forces. Suppose it is T, tension T1. Alright. Again, here will be the T1, here will be the T1. I hope you understand. Here it will be T1 and T1. But what will be the tension over here? If it is T2, my dear students, then you can write this T2 is nothing but twice of T1. This T1 plus T1 will be T2. It means this body is moved by a force of T2 and this body moved by a force of T1. Here the force is T1, displacement is X. Here the force is T2, displacement is Y. And we have obtained here the relation between T1 and T2. This one is, which is very important to understand the virtual work method. And virtually work, what we can say here, the total work over here by this T1 should be equal to the work done by this T2 to move Y. So here the work done, it is what is work done by T1. Directly we can write, my dear students, and we'll obtain the equation as well. It is T1 displacement X is equals to here the T2 and displacement Y. Remember, work is not the vector quantity. That's why we don't think about the direction. The work is going to be done in this direction, never. Work has no any direction. Okay. Now, you can write here the relation between T1 and T2 over here. It is T1 X is equals to T2 is nothing but twice T1 Y. You can cancel out this. So X is equals to 2Y. You can see, my dear students, if this 5 centimeter moved by this body, so this pulley will release 5 centimeter here, 5 centimeter here. Alright. So take total length released by this pulley, it is 10 centimeter and it will move the 10 centimeter. You can see here, if Y is 5 centimeter, then X will be 10 centimeter. Alright. So this one is a very, very important. How much length released by this pulley we have calculated. Now, my dear, so this is called the virtual work method. Now, my dear students, by differentiating this particular, as you know that X and Y is nothing but the position changes by these two bodies. Alright. By differentiating this equation with respect to time, you will get the velocity. Am I right? Yes, by differentiating this equation with respect to time, you will get the velocity. So, differentiate equation 1 with respect to time. You have studied in kinematics. Alright, we are going to use that concept. Here dx by dt, you can write here differentiate equation 1 with respect to time, both side. So here dx by dt is equals to twice is constant will be out dy by dt. Alright, now my dear students, suppose this is the mass 1 and this is the mass 2. We know that if this body will move forward, it will move downward. So let me write here the acceleration A2. Okay, let me write here the acceleration A2. Suppose it is moving with the velocity V1 and it is moving with the velocity V2, then we can obtain here the relation between V1, V2 as well V1 and A2. What will happen? Here the dx by dt, the rate change of position of this body with respect to time will give you the velocity. And it is V1. It is equals to, you can write here how much, twice of the relation between dy and dt. It is dy and dt, the velocity of this one, that is the V2. Okay, so this is the very important, the second equation. Now the third equation, the third relation. My dear students, again you will differentiate this equation. Again, differentiate this equation with respect to time. What you will get? You will get the acceleration, rate change of velocity. It is dv1 by dt twice of dv2 by dt. So here a1 equals to twice a2. You are having the another relation. Okay. So in this way we got all the relations here. Relation between position, relation between velocity, and relation between acceleration. This will be your third equation. Kindly note down in your copy. This one is the very important. In this type of question, that is the constraints body problem, you will see one body is affected by another body. That is, you can see the acceleration of this body m2. It is depends upon m1. Okay. Now, if you will have the relation between this acceleration a2 and a1, then only you will be able to solve the question. Now we are going to solve a few questions, but we are going to write here the simplest equation, that is the simplest method in which we can solve the number of question and the complex question, my dear students. So look at here what we have written here. The total work at this point, and at this point it is constant. You can see over here the total work, it is constant. So you can write the equation in this way, as well as you can write these equations in this way also. Let me draw this one. If you don't know the relation between the tension, my dear students, okay, here it was very simple to find the tension, tension. If you don't know the relation between these two tensions, then what you will write, my dear students, you will write directly, look at here, differentiating this equation 1 with respect to time. What you can write here, the tension, it is constant. Remember, this tension is not going to be changed. Whatever may be the position changed by this m2, whatever may be the position changed by this m1, there will be no change in tension at all. Am I right? Yes. Tension is not going to be changed. So tension will be constant, taken out. So dx by dt is equals to t2 dy by dt. So it is t1, and dx by dt, it will give you the velocity, that is v1 is equals to t2, and the dy by dt, it will give you the velocity v2. So this one is another equation. You can write in this way also in terms of tensions. Then after you can put the value of t1 and t2, you will get the same equation that we have written previously. Now, here again differentiating this equation 2 with respect to, again differentiating equation 2 with respect to time. What will get, my dear student? Here t1 again is a constant, dv1 over dt is equals to t2 constant, dv2 over dt. So it will be the t1 a1 equals to t2 a2. This is the equation 3. The 3 important equation we got. Okay, now we will try to solve the question and understand why we have derived this type of equation. What we got, my dear students, overall the summary of this virtual work method, it is t into x constant, the first, t into v constant, and t into a constant. Okay, now you can see the number of questions we will solve, and we will get the very easily we are able to solve few complex question of competition. Okay, my dear students, let me start solving the question from here only. Okay, from this question we will start solving, and we'll try to understand this virtual, how to apply this virtual work method. Okay, so the first question. Let me adjust. Yes. How many quantities you can obtain here even you don't know? Okay, the mass m, and here I am taking the mass 3m. Remember, m is 10 kg. I am giving the standard value here 10 kg. I used to take these values in all my numerical problems. Okay, now 3m m. You can find out three things. Remember, one, how much position displaced by this one and this one. Second, how much velocity of this one and this one. Suppose in question, if it is given, this body moves with 5 meter per second. If it is moving with 5 meter per second, then what will be the velocity of this one? What will be the velocity of this one? Could you solve? Yes, you can solve, my dear students. So let me start solving this question from velocity only. And then after we will try to understand how to solve the question and to find acceleration, tension in string, okay, tension, what will be the tension and acceleration. Now it is very clear, my dear students, the two body will have, the system will have not single acceleration. You have solved number of questions till now. In that question we had the single acceleration. If this body is moving with A, then all the bodies are moving with A only. All right. But here you have to represent the relation between the acceleration. Okay. First, try to find out the tension. Write down here the T. It is T. It is T. All right. It is also T. What will be the value of this one? It is T, and T how much? To T. Directly we can write. Remember, I am not writing here the T1 and T2. Okay. So directly I am writing here the T, T and 2T. Why? This string is massless, frictionless, and pulleys as well massless and frictionless. All right. Now it is thrice mg. But my dear student, we have to find the velocity. We can use that concept, virtual method, in which we have studied the velocity at this point in velocity and tension, that is the TV is equals to velocity and tension for this one. It is the 2T, and velocity is how much? The 5. T will be cancelled out, so the V is 10 meter per second. So easy. Okay. Now we are going to find out the tension in each string and acceleration of both the bodies. Okay. So in this way we got the relation between acceleration as well. It is, suppose the acceleration A1 and suppose the acceleration A2. So A1 T is equals to A2 2T. Alright. So here A1 is equals to twice A2. Is quite simple. If you are writing this as A, this A2 as A, then of course this will move with an acceleration twice A. Very simple, no? Now you can solve this question. So now you have to use the concept that you have studied till now to write the equation of motion. This body is moving with an acceleration and this body is moving as well. Alright. So let we represent here the positive axis, down and forward, x and y. Here thrice mg is responsible to move this body. So 3 mg minus tension, how much? It is 2T, is equals to, we can write thrice m A. What will be A? A2, which is how much? It is A. Alright, sorry. Here the thrice m acceleration is A. Now this is the equation 1. For this body we are going to write, who is responsible to move this body? T. Is there any force stopping this body? No, no one. So only one force. We will write here that T is equals to mass, it is m, times acceleration. How much acceleration this body have? 2a. It is 2a. Alright, this is equation 2. Adding this to equation, you will get the answer. Multiply by the 2 both side. here this will be cancelled out. So thrice mg, right, is equals to, here the 2 2s are 4 ma and 3 7 ma. So a is nothing but 3 upon 4 times z. So the a is this one. It means this body is moving with an acceleration 3 by 4z and this is moving with 3 by 2z. Alright, it is moving by 3 by 2z. Now, if you got the acceleration, then you can find out the tension as well. Here you will put the value, the tension for this string it is twice T and tension for this string is T. You can write T1, T2 as well. Okay, don't worry. Now, in this equation you will put the value of A, you will get the tension. T is equals to twice M, it is 10, A it is 3 by 4z, 3 by 4, z it is 10. Alright, so it is 150 Newton. T is 150 Newton. It means here the tension is 150, here the tension is 300 and here on this wall the tension is how much? It is 150 Newton. So in this way, my dear students, you have solved this question. I hope you understand this concept, virtual work method, and also you got the concept, you got the idea how to handle this type of question. Let me draw another question over the board and you will pause the video and try to solve by yourself. Then after I'll solve and you will get the idea, yes, from where and where you are getting problem. Let me rub this one. Whenever I used to solve the question, I used to give 3 to 4 seconds. Kindly get snapshot or pause the video and note down in your copy. It is better to write down in your copy whether rather you are taking snapshots. Now my dear students, the next question I am drawing over the board. This one. If it is 53 degree, alright, 3m and it is m, then find acceleration and tension as well as the velocity. If it is moving with the velocity 5 meters per second, then find the velocity of this block. What will the velocity? Also find tension in each string and acceleration of both the bodies. Yes, this is your question. Try to find out, my dear student. Pause the video and try to solve this question. Yes, start solving. Pause the video and start solving. I hope you are solving, my dear students, how this problem can be solved. Now, my dear student, I'm going to solve this question, and this is the part 1 of this constraint body problem. In second part, I will solve few more questions and then we will conclude this topic. Okay, now let me solve this. Here, write the tension. If it is T, okay, if it is T, then this will be the T, this is also the T, and this will be the 2T. If it is moving with an acceleration A1, suppose, and it is A2, we are writing. So we can write for this body T into V is equals to 2T into V. It is 2T into V, that is the 5. T will be cancelled out. So V it is again 10 meters per second. You can see there is no, actually the question is almost same, my dear students. If you look carefully, I the previous question was, it was straight, horizontal, and now I have been just given here a inclination. So you can see here, due to the inclination, there is no change in velocity. You are getting the same answer because there is no friction. Okay. Now, if there will be a friction, might be the answer will be changed. Now here, we have to find the relation between acceleration. Then after we will able to solve this question to find the tension acceleration of the system. So acceleration here, a2 into t, we can write a2 into t equals to a1 into 2t. All right, here the t will be cancelled out. So a2 is equals to twice a1. Again, if it is a, then this will be twice a. Am I right? Yes. Now, nothing you have to do. You have to do all the things that you have studied already. You have to write the equation. Here, the forces, mg. Here, you have to make the plus sign. The tension. Here it is the tension. If it is 3 mg, then this will be, this is the theta, and this is the thrice mg cos theta, and this is thrice mg sin theta. I hope you remember. This is the normal. Now, my dear student, here I am going to write the equations. Equation for this one, we will write which one is moving. This body is moving in upward direction. We take this is as positive axis y and x. Here we will draw the axis, fix the axis y and x in this direction. Okay. Now for this one, who is responsible to carry this block up? It is 2t. So 2t minus mg is equals to mass times acceleration. How much acceleration? It is a. This is the equation 1. For this body, we are writing here the thrice mg. Who is responsible to bring this body down? It is thrice mg sin theta. So thrice mg sin 53 minus, who is stopping this body to move? T. And how much tension? Yes, it is T. Is equals to mass times acceleration. How much mass? It is 3m. Acceleration how much? You can see it is twice a. So it is 2a. Alright. Equation 2. Now what you have to do? You have to compare this two equations to find the answer. So multiplying both sides divided 2, you can write here it is multiplied by 2 and this is multiplied by 2. This will be cancelled out and it is mg minus 6 mg over sine 53. It is 4 by 5. I hope you understand. And here it is twice. Already we are having 13 ma. Here the 2 2s are 4, 3s are 12, 1, 13 m times a. Now you have to solve. Here it is 100 minus 600 into 4 by 5 and this is 13 ma. I think we should take this m cancel out. This m will be cancel out. So it is 60. Alright. And this m is cancel out. Now you can solve here. Ten minus 48 is equals to 13a. So a is negative of, you can see here the negative of 38 by 13 meter per second square. My dear student, again I am telling you, kindly check the calculation. If there was any missing, then you can find. Here, if the acceleration it is negative, what does it mean? It means if we are taking this acceleration body downward, but it is not moving down, actually it is moving up and it is moving down. we have taken the acceleration in upward direction, which is wrong. It should be negative. With which acceleration? 38 by 13. It is moving down and it is moving up with twice of 38 by 13 meter per second square. Once you got the acceleration, I hope you can find out the tension as well. We'll put the value of acceleration in this equation and we'll get the tension in all the concerned string. I hope you understand, my dear students. Okay, now one homework. Kindly write down a homework you need to try in second segment, that is the second part of this video, that is the lecture number 29, the second part, or lecture number 30, whatever. We will understand few more questions to solve. All right, here. Okay, so one homework I'm giving you. We can solve the questions of three body motion as well. It is the mass m. Here it is also m. The thrice m. You have to find the velocity. If the velocity of this block is 5 meter per second, okay, you have to find the velocity of all the block v1 and v2. Here I am not giving the direction. You have to find the direction as well. Okay. What you have to find? If m is 10 kg, everywhere it is 30 kg, then first you have to find velocities, second acceleration, and third tension in each string. Tension in each and tension in each body. Okay, this is your homework, my dear students. The m will be 10 and the acceleration due to gravity you have to take g equals to 10 meter per second square. Okay, my dear student. So this is all about the today's lecture, my dear students. Thank you very much.